Our third representation of data then is the bar chart. So what is the bar chart? Well, it's a way of presenting non-quantitative data. What that means is it's data that's not measured, such as hair colour. Hair colour is brown, yellow, black. We're not measuring it in a particular quantity, so we could use that in a bar chart. Whereas if we had temperature changing over time, temperature is measured, time is measured, that is quantitative data when we couldn't do it on a bar chart. Let's have a look at a few of the things we see on a bar chart then. This is a good example. We've got the y-axis and the x-axis. Hope by now you know which one is which. The y is vertical, the x is horizontal. We don't usually label them as the y-axis and the x-axis, but we do need to label them what the different axes represent. So in this case, the x-axis represents activities and the y-axis represents the number of children. We also have to pick the correct number of squares to use. In this case, because the highest value is 50, they've wisely chosen 1 square is equal to 1 of the tiniest squares. So it's come out nice and clearly. Now, the reason why it's important to pick a good value for each square, or the amount that each square is worth, is if you pick a number that's too small, then the graph is going to be extremely large and could possibly go off the page or be stretched, if you like. So if I picked each square being a quarter, this graph here would be 4 times as big. So from here, from the bottom up to here, would be just the same value as that amount on the graph. So it'd be way too big. On the other hand, if we picked a number that is too large, then the graph would be squashed up and not look as presentable. It would be harder to read. Also, you have to consider how much each square is worth in the sense of what values to pick. Usually we might pick 1 or 2. If the data is particularly large, then 5 or 10. But we don't tend to pick the numbers in between, like 3s and 7s, because when you try to calculate how much square each value or each bar is worth, we get some weird numbers. For instance, if each square was worth 3 and we divide them by 3, we'll get thirds and sixths, and it becomes complicated for the reader to interpret. Another thing we have to notice is the gap between the bars. Very important in bar charts, we don't have the bars next to each other. One of the reasons is that it makes it clear, but another one is that histograms, a different type of chart, looks very much like bar charts, except there is no gap. Or at least one of the reasons that there's no gap. We label the different categories to show the reader what they are. And also we sometimes put the number on top, though I would leave it off. Something else we can do with bar charts is compare within the categories. So in this case, the person has compared the boys and the girls within each category, and notice how the comparison within the category, there's no gap between them. Another way as well, we've got a key to show which bar is which. Another way to do this comparison then is to put the bars on top of each other, if you like, when we're comparing them. So if we don't want them piled next to each other, particularly if there's several that we're comparing, we can put them on top of each other. And then the value will be the difference between the lower boundary and the upper boundary of the category within the category. So in this case, 0 to 4 is for no announcement made, that's 4 people. 4 to 7 is the announcement made by the followers. 7 take away 4 is 3. And then 7 to 11 announcements are made by the leader. So 11 take away 7 is